Hello my dear students, welcome to our channel MS2 Physics, where physics get charged. The last video we discussed the concept of velocity, average velocity and instantaneous velocity. We also discussed the difference between the average speed and average velocity. So now in this video we are going to discuss the concept of acceleration. Okay, so this acceleration can be defined as the velocity of the body per unit time, which means A is equals to, we can write a velocity per unit time. So as it is a velocity per unit time, its SI units are meter per second, so will become meter per second square, or the CGS units are, here we can write centimeter per second square, centimeter per second square. So its dimensional formula can be written as there is no kg, so you can write m as 0, meter is the unit of length, so L, second is the unit of time, and the power is minus 2. So m0 L t minus 2 is the dimensions of this acceleration, and as this velocity is a vector quantity, so this acceleration is also a vector quantity. It is a vector quantity. So when it is a vector quantity, its direction is in the direction of velocity, Okay, so basically the acceleration is nothing but velocity per unit time. Then how could you define this acceleration when body is said to be get accelerated, sir? So for example, if the body moves along a straight line right from beginning, in the 1 second the body moving with a 2 meter per second, and after that it moving with a 4 meter per second, after that it moving with a 3 meter per second, then it is a 6 meter per second. Means here the velocity is in increasing order, of course increasing or decreasing in order. That increasing or decreasing, otherwise simply said to be the change in velocity of the moving body per unit time, is defined as acceleration. The change in velocity of the body per unit time is defined as acceleration, which means here let in the two intervals of time, if in this interval of time t2 minus t1, 4 minus 2 by 1 is a 2 by 1, means acceleration is 2 meter per second square. And I am coming to here 3 minus 2, or between these two, 3 minus 1 is a 2, 3 minus 4 is a 1, minus 1 by 2, means in this interval of time the velocity is decreases, so we got a acceleration is negative. Means here this acceleration may be of positive or negative, or it may be of 0. This acceleration may be of positive or negative or 0. Then how can we decide that whether it is a positive or negative, sir? Or when do we the case we are taking the acceleration as 0? And I am coming to it first this. If the body moving in a regular interval of time with the same velocity of 2 meter per second, 2 meter per second, 2 meter per second, in 1 second, 2 second, 3 second, I am coming to here velocity, change in velocity 2 minus 1 or 2 minus 0 by 2 minus 2 by 2 minus 0. What you will get here is from 0 to 2, t2 minus t1 is 0. Final velocity minus initial velocity is a 2 minus 2 is a 0 by 2. Means it is a 0. Means if the body moving with a constant velocity or throughout the motion with the same velocity, then we will take the acceleration as 0. And the second case, when the body is moving with the increasing velocity, like here supposed to be 2, 3, 4, 5, 6, 8, depends on. We are taking wherever you may take a 2 minus 1, 4 minus 2, 3 minus 0, 5 minus 2 is a positive. 4 minus 2, 6 minus 5 will get positive only. Means if the velocity is in increasing order, then that is said to be positive acceleration, or simply said to be acceleration only. If in this only, if you are taking here it is a 3, then 5, again here it is a 2, then in between these two intervals 3 minus 2 by 2 minus 1 is a positive only. When coming to between these two, 4 minus 2, it is a 2 minus 5, means minus 3 by 2. Means if the velocity is decreasing order, then the acceleration is taken to be negative, and that negative acceleration is said to be deceleration, or also said to be retardation. While solving the problem, if they are mentioning the body get retards, which means its velocity start to decreases and its acceleration should be taken to be negative. Okay students, and if the velocity is a constant throughout the motion, is moving with the same velocity, then the body will get a zero acceleration. This is the way we are classifying this acceleration. Simply said to be, the acceleration is the rate of change of velocity. The change means if the velocity increases, then it is said to be change, or if velocity decreases, then also it is said to be change only. Based on this increasing or decreasing, this acceleration is maybe positive or negative. That is the meaning of this positive acceleration, negative acceleration, zero acceleration. Okay, so now we are defining average acceleration and instantaneous acceleration, and we check the difference between the two. So now to understand this average acceleration, I am plotted the graph by taking velocity on y-axis, time on x-axis. Let it started from origin. So during its motion, I am considered the velocity of the body at two different instants of time. Let it an instant of t1, its velocity is a v1, and I am considered one more instance of time t2, so that its velocity is a v2. So between these 2 points, for a curve, where if you are taking the tangent, is gives the slope. That slope in a VT graph is gives the acceleration. To find the tangent in between T1 and T2, we need to join the line from initial point to final point, from an instance T1 to T2. So here this is what gives V1. Here this total is gives V2. Then definitely here it is gives V2 minus V1 from graph. Okay students, and from this is gives T2 minus T1. Okay, so that here I am defining the average acceleration of change in velocity in the particular interval of time. So this change in velocity can be written as V2 minus V1 upon T2 minus T1 is the A average. Means again, if whenever you are defining the average acceleration, just you are consider the speeds of the body at a two different instants of time of t1 and t2, where you are going to find the average velocity, but not consider the velocities of the body in between the instants of t1 and t2. Means again, while you are finding the average acceleration, it gives the information about the velocity of initial and final intervals of time only. How does the velocity changes in between them? Means other than t1 and t2, if you want to take another time of t3, do this gives the information about the change in velocity? No. Again, to understand this or to know that velocity at particular instant of time during its motion, we are introducing a physical quantity is said to be instantaneous acceleration. Instantaneous acceleration. Okay. And this instantaneous acceleration can be defined as, again, the limit of delta t tends to 0. The average acceleration for any small interval of time can give the instantaneous acceleration, which means if you want to find the average velocity in between the two, again you need to join the line from between t1 to t3 to find the slope. You will get the average. Like that, if you are taking the point here, again it is a steeper. For any small interval of time, if you want to know the change in that velocity of that particular moving body, so we need a quantity, that is what instantaneous acceleration. Whereas the average acceleration is gives just between the two intervals. Doesn't matter what is the velocity in between the two, means at any point. So just we are considering the velocities at these 2 points only. Right. So in this we can write the instantaneous velocity as limit of delta t tends to 0. Limit of delta t tends to 0. The average velocity is nothing but delta v by delta t. So that here we can write v instantaneous is equals to, from basic mathematics, limit of delta t tends to 0 of delta v by delta t can be written as dv by dt. This is what read as the rate of change of velocity with respect to time. Here it is read as what? Rate of change in velocity change in velocity with respect to time. It is, otherwise it is read as dv by dt. This d by dt is the mathematical operator, is called differentiator. When you are differentiating the velocity, so that you will get the acceleration. As in the previous video we discussed that when you are differentiating the position with respect to time, you got the velocity there. So what this differentiator is, we will discuss in the next video, because it is a basic mathematical tool, the differential integration, which are helpful in understanding all the concepts in higher levels of physics, right? So this is what the instantaneous acceleration. Again, the basic difference between average acceleration and instantaneous acceleration is, first one is the while you are defining the average acceleration, just you are consider the speeds or velocities at two different instants, not in the middle of the path. Whereas the instantaneous acceleration, at every instant you are consider the velocity of the body. To understand this clearly, suppose you have started your motion from home, from rest, and then after you slowly starts your speed, velocity of the vehicle on bike 20 km per hour. Next, you are entering into the main road 30 km per hour. No traffic is there. You will go with a 16 km per hour or 80 km per hour also. Depends on that bike and the traffic. Right? So, when you are coming to the average velocity, just you are consider the velocity here and here, the difference of the two and the time intervals, it gives the average acceleration. Does this gives the information about how speed or how the velocity changes in between the intervals, here or here? Does it gives here? No. Understood? Here. So, it is not possible to find the acceleration in between the intervals. When coming to instantaneous, at every instant, you can find the acceleration of the body. That is the major difference. And again, if supposed to be, and everywhere you are moving with a 40 km per hour, 40 km per hour, 40 km per hour, when the body moving with a uniform velocity, then the average acceleration and instantaneous accelerations are same. Means in the non-uniform motion of the body only, these two are different. That is what the major difference between average acceleration and instantaneous acceleration. Okay, thank you for watching. If you like my videos, do like, share, comment and subscribe our channel to get more videos.